my YouTube channel Usha Learning Classes. We are going to conduct video classes of class 10th mathematics CBSE board in a series of videos. We have discussed real numbers in our previous two videos and covered the topic real number, Euclid division lemma, Euclid division algorithm, fundamental theorem of arithmetics, HCF and LCM. Today we are going to continue real numbers and cover the topic as number 1 irrational numbers, number 2 theorem. If p is a prime number and p divides a square, then p divides a, where a is a positive integer. 3. To prove that root 2, root 3, root 5, root 7 are irrational. 4. CBSE board exam question solved. 5. Solution of previous assignment question 2. 6. Assignment question. We discussed irrational numbers in our previous videos. Let us elaborate it some more. Topic 1. Irrational numbers. A number S is called irrational if it cannot be written in the form p by q, where p and q are integers and q not equal to 0. Note, every non-terminating and non-repeating decimal is irrational. Examples of irrational numbers are root 2, root 3, root 5, cube root of 2, cube root of 5 and 0.1, 0, 110, 1110, 11110, etc. Here you can see it is non-terminating and non-repeating decimal. Note, pi is irrational while 22 by 7 is rational. Let us come to our next topic, that is proof of a theorem. Theorem is, let p be a prime number if p divides a square, then p divides a, where a is a positive integer. We will prove this theorem by fundamental theorem of arithmetic, and we know that any positive integer can be expressed as a product of primes. So let a is a positive integer and p1, p2, pn are its prime factors. Therefore, a equal to p1, p2, pn, or and a square equal to p1, p2, pn into p1, p2, pn, or a square equal to p1 square, p2 square, pn square. From fundamental theorem of arithmetic, it is given p divides a square, then p is a prime factor of a square. Now, from fundamental theorem of arithmetics, from fundamental theorem of arithmetics, the only P is one of P1, P2, Pn. But by uniqueness of fundamental theorem of arithmetic, theorem of arithmetic, only primes of prime factors of a square are P1, P2, Pn. Therefore, P divides A. That is, hence if P divides A square, this implies that P divides A. Hence proved. Now come to our next topic, to prove that root 5 is an irrational number. Let us prove now. Let root 5 be a rational number. And its simplest form be A by B, where A and B are integers having no common factor other than 1. And B not equal to 0, such that A and B are coprimes. Now root 5 equal to A by B, squaring both sides, or 5 equal to A square by B square, or 5B square equal to A square. Clearly 5 divides a square, since 5 divides 5b square. Then therefore 5 divides a, since 5 is a prime and 5 divides a square implies that 5 divides a. Clearly we see that 5 divides a. Now consider a number, an integer. Integer c such that a equal to 5c. Therefore this is equation 1. Therefore on putting a equal to 5c in equation 1, we get 5b square equal to 25c square, or b square equal to 5c square. Therefore 5 divides b square, since 5 divides 5c square. Therefore 5 divides b, since 5 is a prime and 5 divides a square, 5 divides b square implies that 5 divides b. Therefore we get 5 as a common factor of a and b, but this contradicts our assumption that A and B have no common factor other than 1. This contradiction is due to incorrect assumption of root 5 as a rational number. Hence root 5 is an irrational number. We can prove it for root 3, root 2, root 7, etc. And this is our proof. Now come to our next topic, CBSE board exam question solved. Our first question is, show that 5 plus 3 root 2 is an irrational number. It being given that root 2 is irrational. Suppose let 5 plus 3 root 2 is rational and its simplest form be A by B, where A and B are integers and B not equal to 0. So 5 plus 3 root 2 equal to A by B, or 5 plus or 3 root 2 equal to A by B minus 5, or root 2 equal to A by B minus 5 into 1 by 3. Or root 2 equal to A by 3B minus 5 by 3. Now since A by B is rational, A by 3B is rational, and therefore A by 3B minus 5 by 3 is rational. since difference of rational numbers rational is a rational. Since difference of rational is a rational, this implies root 2 is rational. But it contradicts the fact that root 2 is irrational. This is because our assumption is incorrect. Hence 5 plus 3 root 2 is irrational. Verified. Come to our next question. Find a rational number between root 2 and root 7. We know that root 2 is less than 6.25 less than root 7, or root 2 is less than 2.5 less than 7, or root 2 is less than 25 by 10 less than root 7, or root 2 is less than 5 by 2 less than root 7. Hence rational number between root 2 and root 7 is 5 by 2. Now come to our next topic, solution of previous assignment question 2. Question was, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both started at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Required time equal to LCM of 18 minutes and 12 minutes. Time factors of factors of 18 and 12 are 18 equal to 2 into 3 square, 12 equal to 2 square into 3. Therefore LCM equal to 2 square into 3 square, that is 36. Hence required time to meet again at the same starting point is 36 minutes. Come to our today's last topic, assignment question 3. Question is, prove that 1 by root 2 is irrational. Try to solve it, and if you can't solve it, then we will solve it for you in the next video. Before concluding today's session, I just want to quickly say that if you like this video or you want more videos on maths, then please subscribe my YouTube channel and hit like button, and do not forget to share and comment guys. Thanks for watching.